Okay, well first I'm going to show you how to do simple linear regressions in Excel. Okay, and these are the examples that are in the lecture. And we're going to first do a simple one with a continuous independent variable, and then one with a dichotomous independent variable. And those are the only two ways you can actually enter a variable into Excel, into a linear regression, excuse me. Okay, now I'm going to walk you through these two options first, and then later I'll show you how to use a different type of independent variable, a categorical variable. That's in the next video. Okay, so here, again, we're going to be modeling data. Okay, so here we've got our dependent variable, which is an attitude about the magazine. Okay, and then we have one quantitative independent variable, okay, which is years in education. So we've selected that. Okay. Okay. Options, just have tolerance checked. Validation, we don't need anything. Unchecked prediction. Okay. What you can use the prediction for is whether you wanted to see, okay, well, let's predict, if somebody had this X number of years of education, what would we expect them to think of the magazine? We don't have missing data. And in terms of outputs, we want descriptive statistics, the correlation, okay? And this is going to help us show why using a regression is better and more powerful than a correlation, and an analysis of variance, okay? Now, this analysis of variance is going to help show us if our model is better than what you would expect due to chance, okay? Charts, there's no need for these charts right now. These are for testing some of the complicated assumptions about regression, which you can read about later in the slides. Okay, so we're all set to go. Let's click OK. And here we go. All right, so it's just giving us the descriptives of our variables. Okay, now here we get some important information about our goodness of fit. One of the ones we're most interested in are the R squared and the adjusted R squared. Okay, the R squared is the same coefficient of determination as we saw under regression. Under correlation. So it's how much variance is the independent variable explaining in the dependent variable. Okay, so about 30%. Then we have this adjusted R squared. What is that? Well, actually, all it is it's taking into account that we have a sample, rather than a population. So ours is about 0.2, so about 20%. That's not bad, except for the fact, if you remember just a minute ago, I told you that this analysis of variance actually tells us if our model is predicting better than if we just use the mean, and we're not actually. But ignoring that, let's look at our parameters here. Okay, so we have an intercept. So all this intercept tells us is where we would cross the y-axis if all the other variables were held at 0. And then our education variable, okay? Now we can see because the probability is greater than 0.05, it's not significant, but let's just talk about the interpretation. What it's telling us is that for each additional year of education, okay, people are going to like this magazine 0.41 less. So you can imagine that the more educated people are, the less they like this magazine. Okay, and here we can also see this is our formula. Okay, the equation of the model. So if we wanted to actually get a prediction, okay, we start out, this is the constant. It's for everybody, this 11.57, blah, 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 blah. Okay, and then we have our coefficient, okay, that, times education years. So if you wanted to make predictions about, okay, somebody with 12 years of education, okay, you would just substitute in here 12, multiply, and that would give you the formula. Okay, so let's see what happens if we try to predict our attitude about the magazine using a dichotomous variable. Okay, so again, we go to modeling data, and we're going to select linear regression. Okay, so we have the same dependent variable. Oh, this wants to switch over here. Let me fix it. attitude about the magazine. Okay, now I no longer have a quantitative independent variable. I have a qualitative independent variable, this female variable. Okay, so 1 stands for female, 0 stands for male. Okay, same options stand. Okay, so we just click the OK. All right. Now actually, see, if we look at our R squared here, we're at 0.614. So we're actually explaining 61% of the variation. That's huge. And the adjusted R squared is 0.56. So that's still pretty awesome. Okay. So here we can see our model, because remember the analysis of variance tells us if our model explains better than the average, just using the mean, and it does because it's significant. Okay, and then we have this intercept. Okay, that's just if every value was 0, this is what it's going to be. Okay, and then we get this effect for female equals 0 is 4.3. Okay, this is significant. This actually tells us, because this is the effect for being male. So this tells us, on average, males like the magazine 4.3 points more than females. Okay, so again, we could calculate this by showing, okay, here's our constant 3.2, that's the intercept, and then 4.3 times whether, this is actually telling us whether the case is female equals 0. So if that's a 1, that someone's a male. So the prediction for a male would actually be 7.5. Okay, we had 3.2 plus 4.3. Now if we had a woman, the prediction would be they would rate the magazine on average as a 3.2. Okay, because this effect, female equals 0, would be 0. Okay, because female equals 1. Okay, so that's how the predictions and the simple linear regressions work. Okay, catch you later.